Now tell me the answer of part 4.
So inelastic.
Inelastic, why?
Because the relative speed of separation is lower than the relative speed of approach.
Yeah, you can say they are not equal. That's it. So you have to explain also, not just write inelastic.
Okay.
Okay, now this part we know that the part is easy. Principle of continuous momentum. I will skip this. Just read part B here.
A stationary firework explodes into 3 different fragments that move in a horizontal plane as illustrated in figure 2.1. The fragment of mass 3.0 m has a velocity of 7.0 meters second -1 perpendicular to line AB. The fragment of mass 2.0 m has a velocity of 6 meters second -1 at angle theta to line AB. The fragment of mass 1.5 m has a velocity of 8.0 meters second -1 at angle theta to line AB. Use the principle of conservation of momentum to determine theta.
Determine theta. This angle. Okay, this angle.
So both the angles are equal, right?
Yes, very. Okay, so see, this is a 3 marks question, and you can easily see that it is a bit, you can say a bit calculated question. You have to do calculation in it. So it is up to you that you have to take either vertical motion or horizontal motion or whatever you want. So I will take here vertical. So we know that before exploding, the speed of the firework is 0, right? Because it already written, it is a stationary firework, so it is 0. So if you multiply by mass, it will still be 0. Now, if I take the vertical motion, so I know that it would be 7 into 3m, right?
Yes, sir.
And for this, it would be minus 2m into 6 cos
6.
this sine theta, sorry, because it is vertical, right?
Yes, sir.
Then minus, then I would be doing 1.5 m into 8 sine
92.
theta. And minus come here because of downward direction. I hope it is clear. Now just have to solve it. Take this to these both to the equal to left side and then try solving it and tell me the answer. Quick. Okay, wait, let me solve, then you just confirm. So first of all, I'm gonna take it there. I will just first take common m and simplify it. Then it would be 7 3 the 15 equals to 12 sine theta minus 1.5 into 8. Okay, it will give us 0 here. Okay, now let's start again. Okay, so if I take it there, it would be plus, sorry. So I can write here 15 equals to 24 sine theta, right?
Yes.
Because I have taken these two terms there, left side of the equal to. So their sign would be changing. Now you can easily calculate it sine inverse of 15 over 24. What is the answer coming?
38.7.
38.7. I One more mistake I have done is 7 into 3 is 21. I don't know why I did write it here. Now do it again.
61.
So yeah, this is the correct answer. So is it clear?
Yes, sir.
Okay, so never uh, think that these type of questions are difficult. It was so easy. I just put the values and we have the answer. Okay. Now read the part 2 and try solving it. Try solving part 2.
Okay, sir. Sir,
Yes.
is the answer 1?
No, not 1. See, they are asking us for the kinetic energy of mass m first of all. So for mass m, 1 over 2, 2m, sorry, 1 over 2 into 2m into v square. The velocity is 6. So 6 square, right?
So, sir, that means you just take the velocity that's at an angle.
Yeah, see, no, we don't need to take the angle here because here it is not written. We have to calculate kinetic energy in horizontal direction or in vertical direction. They didn't ask us to calculate kinetic energy into direction of vertical or horizontal. So we have to take the speed we have already given and the direction we have already given the question. See, have they asked us that we have to take vertical or horizontal kinetic energy? Yes or no?
No.
No. So it is obviously that we have to take the kinetic energy the ball has. And the ball is going in this direction. No problem. We have the velocity, will multiply it with the mass. Okay.
Okay.
So you have to be careful in these things. Don't confuse two other things because this part we have done to calculate the angle. So we have to take any one component because uh, we are talking about all three balls. But here it is just one ball and another ball. So don't confuse it. So now do it and tell me the answer.
3 over 4.
Yeah, right. Okay, read this question.
A ball is thrown vertically upwards towards the ceiling and then rebounds as illustrated in figure 3.1. The ball is thrown at speed 9.6 meters second -1 and takes a time of 0.37 seconds to reach the ceiling. The ball is then in contact with the ceiling for a further time of 0.085 seconds until leaving it with a speed of 3.8 meters second -1. The mass of the ball is 0.05 kilograms. Assume that air resistance is negligible. Show that the ball reaches the ceiling with a speed of 6.0 meters second -1.
Okay, so how will you show it?
Using the formula of v squared equals to u squared plus 2s.
Yeah, see, we don't have a distance, so you cannot use the S1.
V equals to u plus 80.
Yeah, V equals U plus 80. So we have to calculate V is equals to U. So 9.6 plus minus 9.81 into T, which is,
37.
yes. Is it okay?
Yes, sir.
Okay, so see, it is very common in this type of question. You have to use kinematics uh, chapter formulas, sometimes work power energy. So it is the question come with all of the chapter mixing. So you have to be doing sharp when doing it. Okay. Now read part B.
Calculate the height of the ceiling above the point from which the ball was thrown.
Yeah, now you just have to go to S. You already have everything. So calculate and tell me the height. What is it coming?
Okay. $2.86.
Yeah, okay. Calculate the increase in gravitational potential energy from its initial position to ceiling. So we know that formula of gravitational potential energy is m into g into delta h, right?
Yes, sir.
So mass we know already, and height we just calculated it. That would be the answer of your part C. Okay.
Okay.
Okay. Calculate the decrease in kinetic energy of the ball while it is in contact with the ceiling. So for that, see, we have not studied this chapter, but it is the concept of O levels. We know the formula of Faraday energy. So we just have to subtract the final velocity minus initial velocity, right?
Yes, sir.
So what is the final velocity and initial velocity we have?
The final was nine. Eh, sorry. The final was 6 and the initial was 9.6.
No, it is saying while it is contact in with the ceiling. With the ceiling means that the object is still in contact with the ceiling. So now tell
That
me,
means will be
see, this is the speed when the ball is leaving the ceiling. And we already calculated the speed when it is reached the ceiling. Now tell me, yes, Jaspreet. Now tell me what will be the final and initial velocity?
so that means um, 6
First tell
minus
me,
3.8.
oh wait, first tell me what is the final velocity here?
The final velocity is 3.8
Yes. And why it is the final velocity?
because it's when the ball is leaving the ceiling.
Yeah, because we have only asked when the ball is contact with the ceiling. And what is the initial velocity?
0.
No, why zero? Read this line, part A, read part A.
Show that the ball reaches the ceiling with a speed of 6 meters per second negative 1.
So the what would be the initial velocity then?
6.
6. So it is very important to read the question. You have to feel the question. See, you are saying that zero. If the speed is zero, so how does the ball reaches to the ceiling? There must be some speed so that it reaches the ceiling, right?
Yes.
So now you get it. Why will use 6 here? Is it clear why we will be using 6 here?
Yes, sir.
Okay. So I will be writing 6 square minus 3.8 square. That would be your answer, okay?
Okay.
And you already know that we have to find a decrease in kinetic energy. So we already know that velocity is decreasing. It became 6. It was 6 and it become 3.8. So obviously it is decreasing. So you have to write it like this. Is it clear?
But so isn't it like final velocity minus initial?
Actually, you can do it, but since we know that here, if I do it like that, minus 3.8 square, wait. So we have to take this direction of velocity also different. So it will still be same.
Okay.
Okay, so you have to, in the end, no, wait. This minus sign would come inside the bracket. So it will become positive. Actually, the thing is that you know already that in kinetic energy, we don't have the minus sign because of it is a scalar quantity. So you have to ignore minus. So that's why I wrote it like that. Okay.
Okay.
So it doesn't matter you do either like this or that. But the thing is that main thing you don't have to include minus in your sign in your energy because energy is a scalar quantity. Now read part D.
State how Newton's third law applies to the collision between the ball and the ceiling.
So can you type on the screen the answer?
Okay.
Yeah, so think and write the answer because I just wrote the answer of this part in the previous question. if it is difficult to write, you can answer me in chat also.
Okay, sir.
Are you writing it?
Yes, sir.
Why is it taking? Okay, the force acting on the ball is equal and opposite to force. See, the force acting on the ball is equal and opposite to the force acting on the ceiling. Here are no two balls. Here are ball and a ceiling. So you have to replace object B by a ceiling. So you will write the force acting on the ball is equal and opposite to the force acting on the ceiling.
It's a typo error.
Yeah, and this okay.
Hey guys, this is Philip.
So now read part E.
Calculate the change in momentum of the ball during the collision.
Okay, so the mass we have is 0.056 into velocity, which is 3.8 final minus initial. That would be your answer. Okay. Is it clear?
Yes, sir.
Because during the collision, we have just these two speeds which have changed. Okay, calculate the force. So you know the time already. You have calculated delta P above. You can easily calculate it.
Okay.
Determine the magnitude of average force exerted by the ceiling on the ball during the collision. So we know the answer of part E is 0.55 and the time is given to us 0.085. Tell me the answer of this.
0.588.
Sorry, the answer would be 6.47 here.